All right. I think we're live.
Oh, really? Nice.
Yeah, very nice. Okay, cool. Have you been on live stream before, Kevin?
No, I mean, not like this. That's why I said it's fancy.
This should be pretty fun. And welcome to, or thanks for being open to trying a live stream for the first time. It's some people say it can be quite daunting if it's the first time. I actually get a little quite nervous every time I do
I mean, for
it.
me, I just thought like, it's just conversating with you.
Yeah,
It's nothing like crazy, I guess.
yeah, just a very informal conversation. I think people find value in just like some of these informal conversations at times too. So,
I think so too. Yeah.
okay. But for anyone that is tuning in or people that, because this is going to get recorded later, people could come back and rewatch it. Um, Kevin and I were just in the middle of like probably like 5, 10 minutes into the conversation about talking about different pathways, biomedical informatics, computer science, and biostats in a way. But any other pathways are open too. So I think this conversation comes up a lot, and I had interrupted you before I very abruptly asked that you can we talk about this on live stream? So let me actually before I jump into back to what you were saying, anyone that's interested in joining the conversation is welcome to. We have a little thing here for you to join. You can jump right in. I'll post it in the chat as well. And by the way, Kevin, this is streaming to LinkedIn, YouTube, Facebook, Twitter. I think it might be one more. Twitch. Yeah, Twitch. So
Oh, sweet.
just FYI, no one watches Twitch for this, but anyways, okay, cool. So what were you saying at first? Before I interrupted you.
Um, I think we were talking about like I forgot the question, but I think you were asking me like what I guess in a way like what happened, like what makes you wanted to go like CS route or like not biostat. I mean, because stat CS kind of created sort of the data science thing, and so there's like a bunch of discussion on whether they want to go stats and go to programming, or they want to go CS and they want to learn about stats like in the different ways. And so, I mean, I did a lot of exploration. I checked a lot of, I've talked to a lot of friends who's in biostat or like in CS or even like working already in industry. Like they asked me like, why, like, what do you want? What was your focus? And so I was told that like I don't really care about math. The math essentially for me is tool. I'm not like super focused on like why does inferential model matters or like the very like in the theory way, I guess.
Mm.
And I was told by my like a close friend of mine, which he is in biostat in Hopkins, and he's about to graduate. He was like, well, biostat, like essentially you look at it as a stat and you learn bio application to using stat method, but essentially it's a stat. And so like it's very mathy, if you want to say like it's it's very pretty much a very sort of like a subdivision of like a apply stat. And so you got to really think about if you really like math enough to a point that it's very to like philosophical level. And if
Mm.
you don't, if your main goal or your end goal is not so, to that extent, like trying to create something in the stat world or trying to discover or trying to do very heavy theory research then or academia and stuff, then I should go for like a data science or comp sci. And so that's sort of where I'm coming at.
Well, let me. This should be interesting food for thought. Is I would also say that both biomedical informatics and comp sci and data science all have pretty complex math within it. And now I was prepping for my next class, so I'm taking, I don't remember what it was called. It's some type of imaging biomedical informatics course, and we jump into learning deep learning. We'll be building deep learning models, CNNs specifically. And as I was preparing for this class, which starts in like 2 weeks, I was just looking through different deep learning introductions, and it's very math heavy. And like you, maybe in the sense that I'm not a huge fan of math either. Like I don't want to dig so much into the theory, but I have a feeling as that if you want to jump into any of these fields, there's definitely going to be some mathematical component. Maybe
Oh,
what
I
you're talking
agree.
maybe what you're talking about is like the how much exposure.
Right. One is applied and one is like to the very like
Uh,
you're proving a, I don't know, you're proving a theory or you're proving some sort of thing. Compare that to application, I think.
and you're more interested in application.
Yeah.
And that
To
brings up a
me,
very
building a tool is more interesting.
yeah,
That's what I'm getting at. Yeah.
completely agreed. And I think this is what for me personally, it's a little hard to answer the question sometimes in terms of like this whole topic is like I think computer science is much more theory. I mean, there's obviously applications. Like many of the CS
Right.
courses, you have to build something, but there is a lot of theory in the courses, and I've always felt as though biomedical informatics is like an application of computer
Oh,
science to like some healthcare domain. But that's been bothersome to me at points because of that. But yeah, I don't know. I mean, these fields are so related, anyways, and
yeah.
then the
It's like so different but so related because they're all very focused. And
yeah.
I mean, if you have a good math background like a stat, you obviously are definitely, have an easier time to understand some of the like CS concept. And same thing the other. And so that's why I feel like towards the end, I think it's kind of hard to say, but to me, I just thought like after all this exploration, talking to people, I think data science or CS is sort of the thing that stood to me. Like whether I guess I care about math in this sense that I wanted to do something with it, or I care about using math as a language and concept in sort of computer science to create a tool or build something that makes life easier or makes healthcare better.
Why don't we get into some of the concrete examples? And by the way, there's a lot of people watching on live stream. So if anyone that is watching, leave a comment or chat about who you are, where you're from, things like that. If just so we know who's watching. But anyways, why don't we get more concrete with some of the examples here? Because like this is something I'm personally trying to figure out myself in terms of like what do I ultimately want to do? Like very similar to you, I want to build an app and stuff, but then maybe I should be going into biomedical informatics more so than computer science. Do I want to do research papers? Kind of too. So like just like a mixture of things. But let's get more concrete with examples. What are some of the things you actually want to do? Like build a tool, but what kind of tool? Like give me some like, concrete examples.
Like, I mean, it's like, I don't know. You can see a lot of problems everywhere. So for my background, like in this case, from a public health background, how do we sort of connect the data together? How do we have sort of a gateway to connect EHR to to the real world application that people can just use? That is, I mean, catching up from like what is in the industry to sort of Commonwealth to Department of Health to everywhere. I mean, that is a big tool. I mean, but that needs a lot of, I guess, CS. It's not just the data science right? Like data science is almost like a downstream. You're kind of like a data architect or data engineer. You're creating sort of ways to sort of connect them. That's one way. I mean, you can say fire HL7 as one big way, but that's also built on a lot of CS concept and stuff. And if you want to learn more about those, I mean, that's
you're plugging
like,
you're plugging some fires. No, okay, this is gonna be a very interesting conversation because I want to get your thoughts on this. But let's acknowledge the comments real quick. What's up, Tony? I think we all know Tony here. Thanks for tuning in. Jeremy, I don't think we've met before, but thanks for tuning in. I try to stay off of TikTok because I don't know, Kevin, are you on TikTok? It's a very...
I mean, I follow the news, but I'm not on it because I don't want my information to...
Oh, that's why. It actually gets very addicting, so I stay off of TikTok. Jeremy says blockchain and CGM, both very interesting topics. But what I want to get to you, which is why those are kind of the things that have been on my mind in the last few years. So like you brought up, how do we connect all the data and stuff, right? And I think this is where I think it's not just one thing. I used to think like, oh, we have the tech, we can solve everything. Or we have the clinical expertise who can solve anything. I think when it comes to things like that, especially like nationwide or global, or even like sometimes within your own organization, it's also political. You have to be able to maneuver the red tape to get certain things done. And I think before going deeper into computer science, I actually ruled it out a couple of years ago, and I actually came back. I had ruled it out because I wanted to pursue a master's in public policy or a doctorate of public health, because both of those would allow me to better understand how to navigate the red tape, because you need people, you can't just build the solution. You have to be able to like get people to adopt it. But now I'm gravitating back to the building the solution part. Of course, you still need to figure out how to get political buy-in to implement something like that. But kind of derailed from your comment there. Can we talk more about that tool you want to build, like what exactly that tool looks like in terms of like connected everything? Or is it Fire? Is that what you're thinking?
Yeah, Fire will be one of the solution, I guess. But then also like you think about what is Fire? Like Fire, when you build resources, you do the rest, like the RESTful like platform, and you kind of push and pull, or you update and stuff. I mean, that could be the data that you get, but also what would you do with the data, right? So that's where I feel like that's why I wanted to do like sort of advanced degree to really hone in on what to do afterwards, because all those data would be almost nothing if no one's know how to use it, or you don't know what to do with it. And so that's when sort of part of me was like, at my job, I was like, well, I do want to learn more about what to do with it. And so I went into natural language processing.
Interesting. So it sounds more like, if we're talking about, this problem of, it seems like healthcare interoperability, there's the beginning part on how you share data. It seems more like you want to know, you're assuming that at some point that'll get solved, and then we're gonna have to figure out what do we do with that data. So you're more interested in this piece then, not so much okay, cool. And that makes sense. So you want to build something that either extracts value or of some sort.
Yeah, at least like you can do, text mining, or you can, I don't know, use GPT-3 or 4 at least to interpret or classify some of the text, or I don't know, BERT, like the BERT-based methods. You can kind of see sentiments, or even like trying to interpret what are all these trying to say, or is there a diagnosis in these notes, or what were the sort of overall overarching data structure looks like? Because I mean, I guess it relates to what I do. I'm like super interested in like how do you meaningful use, like what's the meaningful use for the data, and also how would the data structure related to the meaningful use, and you have to make sure that all the data fall into places as like format wise or as like application wise, so that they can be used and not it's like used as like analysis, doing research, feeding into maybe even Power BI, things like that. But beforehand, how do we present it so that it's good? And I feel like that has a lot of CS in it that I feel like it's
Oh my goodness.
it's whiny. Oh yeah, I saw that.
Okay, maybe we can take a pause and read Richard's comment here. It looks like Richard's got a lot of. I wonder if I can show it here. This might be easier. Oh no, but it hides it. Hold on, you just have to read it. This is from LinkedIn, so I have LinkedIn open too, so we can just read it on LinkedIn here. Okay, here it is. So in answering what you want to do, one way to focus is to reverse the order of requirements. Instead of focusing on skill set first, focus first on the broader category or function. Trade or skill set, I'm a program manager, but if searching for a career that's satisfying, I want to look for a program manager role. Look for a broader opportunity, such as one that allows for team and relationship building, one that allows for driving towards solutions and technology. These broader areas make me happy, and my skill set as a PM naturally allows me to be good at doing those. That's the real conversation. You can always learn a new skill set. First, find the environment you want to be. What you want to react to that first, and then I'll take it afterwards.
I mean, I agree. I feel like that is sort of. I mean, I see a lot of that in my work. Like, you need to interact. You need to build relationship. You need to actually, I guess, adapt and learn. You need to communicate to find a solution, to find or to even navigate, right? Navigate resources. That was sort of, I guess, one of the big takeaway in the 2 years, I guess, in my CDC journey is that you got to speak up. You got to check things out. You got to go social, or you got to go connect with people, and you got to attend to meetings and make sure that you take a good note on what's going on. And so I kind of agree with that in a way. But for me, I feel like that is also a skill set. Like that's like almost like a character you can go into. But also for me, I see myself as more like, I don't know, it's like I'm more interested in the building side. But I guess, I don't know, it's like you can apply to both, right?
Yeah, and I think Richard has a really good comment here, and I think that was like what I was hoping to do with this conversation initially. Is like we have three big categories right now: biomedical informatics, computer science, and biostats. But going to one of the earlier things that I said about how I originally said I didn't want to do any of these things because I wanted to do a master's in public policy or a doctorate in public health, is because the bigger picture and goal in my mind is purely to connect healthcare data. It's not a skill set, it's like a goal. And then it's like, initially my mind was like regulatory issues, not really regulatory issues, it's just the red tape. The red tape in government is the major barrier in my mind in solving that issue. So I wanted to go that route. But now I'm finding more fascination with the building side, because I know a little bit more about how to navigate this piece. Now I want to learn more about the building. So ultimately, it's the bigger goal that I had, or the interest rather, that drove which skill set to pick. And I think that Richard's trying to make that comment too, in a way, which I think is a very interesting one, which maybe we can dive more into, is like what are the things that excite you and what makes you interested in building things? Like let's use this is a great thing that I like to do. It's called the 5 whys. So you said you like to build things. You let's say you want to make use of let's go with that last point. You want to make use of a lot of data. Why?
Oh, because it gives you insights. It gives you gaps, and it gives you, or like it gives you solutions. So, I mean, overall, I mean, what I'm trying to describe is it gives you insights to a problem.
Okay. So why do you feel as though you need insights for that problem? Like it should get more concrete. Like for you, like specifically, why? Why do you care about that? Is there a particular problem you see that made you say that? Where there wasn't enough insights, maybe? Like
I guess in
why?
many different ways, right? Behaviorally, or so when you get a set of data, you can see how things were captured, to how was it processed, what was eliminated, what was filtered, and you get to explore in the data, and you get to know what the limitation is, and so you kind of know what happened to the data and how would you use it, and in a way that like it would show you the picture. To me, it's almost like a visual picture of what's going on for a mechanism that's moving, that's like acting. It could be a data exchange, it could be you administering a shot, it could be you, or it could be anyone that's in this world that somehow turn on the cell phone, put on the location, and like that could be a data point. And so I feel like it's really interesting just to learn about human behaviors and answering some of the big questions. I mean, that's what sort of intrigued me, I guess, and also pull me in.
I'm wondering if we can even go more layers deep. Is like, okay, that's interesting. So are you mainly chasing curiosity? Like, is it just because you find it interesting, or like what is like what makes Kevin wake up every morning and say, this is something I care about so much to the point that you want to pursue another degree? Like, why do you feel like you want another degree? Like, what is the motivation behind that?
I think for degree is almost like another higher level than the question I'm trying to answer. But for the degree, it's more like exposures and connecting to, I guess, broader people, like different groups of people, knowing different things. Because I kind of enjoy like working with people with different backgrounds. I mean, you learn from different backgrounds. You learn their perspective. You learn their pain points. You learn about their difficulties, or maybe even their lives or their problems at jobs. So I feel like that's where you get to broaden your perspective on, let's say you're going with the same problem A, like, I mean, both of us are in like health informatics. Let's say data exchange. Depending on who you talk to, everyone has their own solution. Everyone has their own perspective. Maybe some people will be like, yeah, let's, go with like HO7 fire. Like that would be for some people, that would be the solution. For some people, that could be a little bit different.
It's a question for you. So, I wonder if I can this one connect to display. Does it get cut up? It always gets cut up. I don't know why it does that. That's unfortunate. Why don't you take it away if you want to?
Yeah. So currently, I'm a public health informatics fellow at CDC, and I always need to do this disclaimer. So my opinion doesn't represent my job, because this is just fully, my education,
Yeah.
my opinion, my career goal and stuff. But yes. But yeah, I came from a clinical background, and also a little bit different background than Brian, is that never really implemented EHR, because I kind of grow into sort of like when I was in pharmacy school, that was like the big boom. And then when I come out of it, it's like real world data, everything now. And so it's like now I'm, I guess, in a way, helping the public health to connect the data together.
I'm still reading his question too and trying to process it.
Yeah, I'm partly reading, partly answering.
The immediate first comment that I have, thanks for the question, by the way, Fola, to the learning health systems aspect, and maybe this is completely off too, is that a couple thoughts. The first thought is one of my new phrases I love a lot is innovation is orthogonal. It happens at the intersection of two very different things. Going to your point you said earlier, one of the reasons why I like to learn different things is because that's how innovation happens. And I was just thinking about that also when you were saying it, and now with Fola's question is like, learning health systems is not a novel concept. And that has been taught so many times, but like, why is it that for the last like 20, 30, 40, 50 years or something, like there's a JAMA article about it, just came out last year. Why is our GDP 5% so many decades ago, and now it's 20% of GDP healthcare spend? It's absolutely insane. Like we are not innovating in healthcare. We're just getting worse. Like for the amount we spend on healthcare, the innovation isn't there, or we're just not being efficient. So going back to that other point about learning is like, we need more innovation to figure out how we can do better. And I don't know, I feel like I'm just ranting now. Anyway, yeah, that's, I don't know. Did you have another comment to the last part?
No, I think you kind of, I kind of had the same thought as you, like learning. I mean, it's like intersection. I mean, that's what I'm trying to get is compared to, I guess, in a way, compared to biomedical informatics, I feel like CS degree might gives me a different lens to look at things. And that is, to me, that is sort of the gold that I want to get at is now I'm looking at it like when I graduated from pharmacy school, I look at it straight up from a sort of clinical lens, although I don't think I can claim that, oh, I went through PGI 1, 2, had that specialty. But now I'm in public health. I see lens through public health. What is the problem? What is the solution? And I want another perspective from a very different perspective, which I think CS might gives me a little bit of that instead of me getting stuck on the resources and solution what I got. I want a different, I guess, like a fresh view of the same problem, just to prove that, I guess, you have another ways or you have gaps that you need to be filled in.
Yeah, I for some reason I just like blanked out and remembered that you have this like 2 years of experience in public health now. I think transitioning from a provider mindset where you're focused on one patient to populations in public health really changes how you approach problems, and it's super interesting. It's just a random comment. And then back to kind of related to Fola's comments here at first, a rebuttal to one of the things I said earlier is that I do actually, it's never like black and white, right? I do actually think that we are at a unique turning point where pursuing things like CS or even biomedical informatics or biostats, one of these, maybe computer science is the most interesting one, is that I think there's some unique technologies that have been solved. And I'm going to steal this from the deep learning lecture that I watched yesterday, which is like big data is another one. We're generating more data than we ever have before. So maybe my argument earlier about decades of doing this is irrelevant because we didn't have that kind of big data. The second thing is that there is new open source tools like TensorFlow that allows us to create certain models and at scale. And then the last one is like compute power. Computers always just like, get better and better with these technologies. And the compute power we have nowadays allows us to actually perform some of the unique things that a learning health system would do, that Flo was talking about. So perhaps some of the things I said earlier is negated by that. And what's a good example? They talked about the gradient descent, which is a method, and it was like discovered in the 1970s. But it's I can't explain it. It's deep learning stuff that I'm still learning. But it's just like minimizing your loss functions to like optimize your model. And it was discovered back in like the 1970s or something. But we weren't really able to do a lot of these things because we needed those kind of three things: big data, compute power, like open source tools to really do it. So.
I mean, yeah. I mean, I can say an example, like, back in like early 2000, we have cluster computing. Now we have the cloud computing. That's a huge difference.
You're right. I forgot. Yeah, cloud computing was a big one too. That's a pretty big thing.
I mean, now you just need to hook up to a virtual machine and run the models, train the models. I mean, that was sort of, you don't do batch code nowadays. You can just hook up a Colab or some sort of Docker and just work with it.
So what was it? You want to react to Fola's comment, and then we any comments there?
Oh yeah, I agree. That's the part of me feel like, after 2 years, people were like, oh yeah, I need to like transition into like certain role and stuff. But to me, I always feel like, I need to learn more. I need to keep moving. I don't know why. Maybe it's just me being so like, I don't know, so curious and so hungry about new stuff that I wanted to do it. I sometimes like pushing myself on that because I'm like, when do you feel is enough? When is enough? Like, but then I feel like in tech, in health tech, or even I feel like in anywhere, you gotta move forward because we're talking about data. Data is moving really fast.
Yeah. I feel like we're going to deviate from the topic. If I asked the next question, which would have been like to dig deeper into, where is the curiosity coming from? Because that's something I'm genuinely interested in. But that's going to be a little beyond the topic, so let's not go there for this one.
I guess tying back a little bit. I mean, going back to curiosity, I guess tying all together back to like why CS, why BMI, or why biostat and all that. I think it's that satisfactory. I think when I imagine a wonderful day at work or anything, it's like, dang, I killed it. It's when I feel like I've created a crazy prototype function or crazy prototype platform or a dashboard or anything that I know it's going to be an impact, that I know it's somebody's question a long time ago. That is sort of the fuel in me that gives me, I guess, motivation to learn more and sort of push me to, I don't know, biomedical informatics or CS.
And maybe there's probably some people that will watch this or watching right now that might be interested also in like our personal rationalizations as to why one or the other, or one of the three here, or maybe other fields outside, was not on our ultimate list. But we should probably also tell the audience like what we are currently pursuing, and then what are some of the rationales of why we're not pursuing the others. And maybe I'll just like kick it off real quick because it's always good to get some validation on if it's the right move. So I am doing biomedical informatics graduate certificate right now, but I'm going to be going for computer science. And it's like a 5-year program. But my rationale for doing so is because I've been exposed to biomedical informatics like for a quarter of my master's in public health degree. So I spent a lot of time in biomedical informatics, and like many of the concepts there, I was able to also learn by doing when I was still working in the hospital at Mayo. And so biomedical informatics is great, but it's comfortable. And I'm not an expert, but I've done it for a little bit. Now I want a little bit of the, something different. And biostats, I mean, I have an MPH, so it's pretty much all stats. There's a lot of stats involved. That's like our bread and butter. So I'm not pursuing biostats because of that reason. And then computer science, probably more so because like it's a mixture of things, like being able to look at problems from a different perspective and then combine them to create a solution, but also because I want to build something, like truly build something from the ground up. So that's like kind of my rationale.
So for mine, I think just a huge split difference is that, I mean, I don't think I have the MPH degree to say about biostat, but I think I've been in like my work long enough that I feel like there's a differentiation side of things is, from biostat epidemiology to like health informatics, they do very different stuff. Although there's overlaps on like data science side, but the perspective is a little bit different. I would say a lot of time I relate more on the health informatics side just because from maybe a healthcare background and never really went into mathematical modeling, like that kind of model, not the data engineering models. And to me, that was sort of an interesting thing because it's like you built something and people used it and you see the outcome out of it. And I mean, I feel very proud at the end of the day, like, hey, this thing kind of worked. Hey, I don't even expect like this outcome to be this good. But you built a solution to it. And to me, that was like the ultimate, I guess, sort of the goal that I wanted. And that sort of helped me or pushed me to go into like deciding why you want to go like biomedical informatics or you want to go CS. But eventually, as I learn more and get certified more on Coursera courses, I just feel like, yeah, I think I have a lot of catch up in CS to do. Than just knowing how to applying things to in like a bioinformatics problem. And so to me, I feel like unless I grasp on that concept, I feel like I don't know if I don't know. To me, it was like, I don't know if I really needed that application experience than the very fundamental concept for just CS and data science and algorithm design and all that.
I'm going to make the comment anyways. It hopefully doesn't derail the conversation in the sense that like, so I see that you have a insane drive that you want to keep going. And obviously your comment, especially about how much catch up, I can relate to that in many ways. And I want to ask the question of, you made the comment too of like, when is enough enough? I actually think a lot of people who go into like software engineering say this quite a bit on blind, in the sense that like in these technology fields, especially if you're like a software engineer, you have to constantly learn. Technology changes so often. You're just learning and learning and learning. And I think I always see comments from them. It's like, when is enough enough? Like, when are they done grinding? Because the moment you learn something new comes out, and like you have to keep learning. So more so maybe the question to you is like, when is enough enough? Because it's an infinite amount of information out there in the world. Like, when do you stop? Like, what is your goal? Where would you define, or do you have any like endpoints that you would like to define? When would you've accomplished X, where you would be like, okay, I feel good? What is that for Kevin?
I don't know. That's such a deep question. I would say never.
Never. Okay.
Yeah, I have a feeling like this is the tendency I have. Like, I think this is just like a tendency I have. I think I found out since high school that I would like dig into things and just keep on going and going till like someone told me to stop. So I would say probably in a good way that I probably won't, but in a good way that I guess I'll grow.
Okay, well, what about this? What are some things top of mind that you feel, or not feel, like you feel getting a CS degree will help you be able to solve? Like, let's get back to like more concrete topics. Like, give me some examples of things you want to solve.
Oh, one big thing, efficiency in programming. So that is big because I feel like constantly when I code in R, Python, I don't know, like those two are the main ones I go for. But the problem is a lot of time I feel like I did the code, it worked, but I don't have assessment or a way to really know like if it's efficient or not. Because it works, but is it efficient or not? Not sure. How do I know like I mean, it's probably like somebody's job to write test softwares, to run their tests on their softwares and get repos and stuff. But it's like how efficiently can you do in a code, and how can you do a code so that it's well produced? Not only that, it's sustainable to the life cycle of the software, to the life cycle of maybe some project, so people can take on and still reuse your code or rebuild your code. I think that is something I need to really work on, especially after doing like leak code, a bunch of them, and I just thought, man, I'm
why
out of it.
why is this a topic for you? Like, why do you care about, if it, like, did something happen like specifically where you care about this? Like,
I mean, a little bit. I feel like if I mean, it would be fine if I don't do a lot of code, but now I'm doing a lot of coding or like looking at codes. I just feel like I don't know, it's not great to have an like efficient code, or I don't know, a very fat code, I call it fat code, that it runs but it doesn't do as much of job, or like it runs but it doesn't do well. And especially in, I guess, if you do a lot of code, you know that that is something that it will be there if you push it to prod, or I don't know, to an application. And I don't know, maybe I'm just perfectionist, that in that way I feel like a lot of times I want it to be as efficient as possible so I can build more stuff on top of it. But the problem is I feel like I code, but I'm not sure what's the sort of ways to assess it. And also not only that, I think that was just one little factor of it. I think the biggest factor is what are some of the very like fundamental concept of computations that created this code that makes a function happen, or how do I design a system efficiently that it serves the purpose of healthcare application, public health application, or anything, like beyond what EHR is. How do you why like almost like you're asking yourself after HL7 classes, like why do they choose XML or JSON than other stuff like CSV? And so I mean, I asked myself a lot of that, like very fundamental question. And what is HL7 even is? Why are they being, the sort of API that everyone now uses, or a lot of people uses, to solve data exchange problems? And are you able to find a flaw, or are you able to improve from there? Because I think eventually how the way technology is, something new is going to happen, something better is going to happen, and you got to sort of ride the wave out of it. I guess, in a way. And you got to know sort of ways to improve your current model and move on.
So a couple of comments that I think the first one is that a great way to optimize your code is just to put it into ChatGPT. I'm not even joking about that.
I kind of disagree with it.
Well, okay. Well, wait. Let me make a couple points first. So, I think ChatGPT can do a great job in optimizing code. Now, could it write some terrible code that messes up? Sure. Is it wrong a lot? Sure. But in terms of like, actually, well, who is it? So Folo's comment actually made me think about that in terms of like partnering with others. I do think like there is something to be said about learning everything on your own versus like learning something really well and being an expert at it and then like partnering with someone. And the reason why I bring that up is because I look at ChatGPT as one of those tools. I don't think it'll replace like a great developer, but it will very strongly augment clinicians who have an interest in, let's say, optimizing code. Like, can you spend a lot of time learning how to optimize code? Sure. Is it the best use of your skill set after spending like 4 years in pharmacy school and 2 years in a public health fellowship? I mean, maybe, yeah. But I'm just saying, like, that's something I think about a lot is like, should I really learn all this? Which is why originally I didn't want to pursue computer science because I felt as though my skill set was better served elsewhere. There's a lot of smart technical people that I'll never be able to catch up to that. I'm not going to pursue that route. But the other thing that you were saying about optimized code makes me think of two concrete examples with biomedical informatics and computer science. There's a lot of videos out there that talk about like building something, right? You're like, oh, I need to let's retrieve data from some website using an API and bring it in, and then I need to like clean the data and like modify some things, create some columns, and do some analysis, all this kind of stuff. That's not efficient. It's efficient when you break down and compartmentalize different things. And I remember watching someone, it was actually a data scientist, and was saying like, let's do good computer science principles. I was like, what the heck is this? And he took all of this code that he wrote, it was like step by step, and he compartmentalized it into reusable functions. So I think it's a great example of why learning some of these like core computer science skills is excellent. Now, the other thing I think you said it made me think of it at least, is biomedical informatics. So when I started taking biomedical informatics courses, I was like, man, I could be building these things a lot better. And what example I'm going to use is value sets. So like, let's say you wanted to build a clinical decision support rule for pneumonia, right? And you wanted to have a value set of anti-MRSA agents, right? You might say, okay, I need to build a new value set. I'm going to create a new record. I'm going to call it this anti-MRSA value set for this pneumonia order set. Cool. Then there's like the nephrology team says, I want to order set for UTI. And we also want to have MRSA treatment. This is probably, this is not appropriate. But anyways, they want one too. So you're like, okay, I'm going to build one and another value set and put the anti-MRSA agents for it and put it in there. That's not efficient. Biomedical informatics teaches some principles in terms of knowledge engineering and knowledge representation. We're talking about knowledge graphs and ontologies. When you build things this way, you build things in more modular building blocks. And I think a lot of this actually comes from CS, where it's like, okay, anti-MRSA agents is a concept. Fundamentally, it starts here. And then you might have these like variations of it, but it will always pull from here. So like whenever, let's say there's a new anti-MRSA agent in town, you would update this concept down here, which would then populate these other things. That's how ontologies work. You know, I think these are like great use cases that you were kind of talking about them, that I encountered personally, that I was like, man, there's a whole new world that can teach me how to do my job so much better. But yeah, go ahead. So you had disagreements with the ChatGPT comment, and you maybe have some other comments to that. What?
I mean,
What
I
about?
think you nailed the ChatGPT comment. Like that's why I think like ChatGPT. Yeah, like you said, I think. I mean, even for artists, right? Like GPT or Deep Learn, like Dolly, if you know, creates pictures. I feel like those stuff are more assist of like what you're trying to do, but they didn't really have an idea on their own. So like idea is still yours. You want to create that thing. They basically help you illustrate that, or ChatGPT, you got it, kind of got to frame it right and then put the question correctly in order to have the right answer and all that. But if you ask them like very like probability question, like very heavy stats question, they might answer it wrong too. And also if you ask them like what to eat within DMV areas, they might give you some restaurant that's already closed. So I mean, I feel like there's some errors, but ChatGPT, what it does is they give you the sort of the highest probability that's being the correct answer to you. And so to me, it seems like they could optimize it to a certain extent, but I feel like that's to their limit of how they were trained to do. But towards the end, I feel like there's need to be a human component to it to create a content or to create a goal, to create a direction, or even to optimize it. Because the problem might not be the code, might be the logic is totally just off, or the question that the problem solving solution that we're trying to tackle, the direction we're trying to tackle is totally just maybe it's not at the right point, or maybe could be done in alternatively with an easier route. And so who knows? And so that's how I think ChatGPT is.
There's good use cases and there's bad. I
Oh
do
yeah,
think
yeah,
like
definitely.
one of the difficulties with ChatGPT that I have is like, or rather concern. Is it? Yeah, it's probably more of a concern. Is like I feel like it's good when you can ask it really good questions. Like for example,
Yes.
if you don't know what you're doing and you ask, let's say optimizing code, we'll use that example again. If you just dump it in there and you ask it to optimize the code, it can do a lot of great things. It'll probably like compartmentalize a lot of stuff into functions.
Or
And then
soft
you
code
might be
workflow.
like, yeah. But then like if you don't really know how to code yourself and you're reading, you're like, oh, this looks good, but maybe it's like bad. But you're not able to tell because you don't have a certain level of threshold. So the main point I'm saying is that I think you have to be very careful with how you ask the question, and also have enough knowledge to say that was a bad answer. That was a really bad answer.
Yeah.
One example that I remember, I dismissed ChatGPT. I was using it like the first week. I was like asking it questions about pharmacy informatics. I was like, this is pretty good because it knew a lot of things that I would say myself. But then one of the things I asked it was like, what certifications can I get in pharmacy informatics? And they're like, you can get board certified in informatics. I'm like, no, you can't. That doesn't even exist. And they came up with the acronym for it. And I was like, okay, this. And then I brushed it off after that. I was like, it's making up information, which is weird. But I
Yeah.
guess, yeah.
I get that with the restaurant question though. Making up restaurant names. I'm like Yelping it, Googling it, search it anywhere. I was like, it's not even, it doesn't even exist.
Oh, that's kind of funny. I didn't know it made up restaurant names.
Yeah. Or it would search out like a restaurant that's been closed like, I don't know, 10 years ago, that it could have been, I don't know, existed. It's just funny.
Okay, I didn't. Yeah, it's super interesting. But like, given that it's a LLM, it learned from something, right? So like, maybe
Mhm.
someone suggested some fake restaurant like ideas or something. But I didn't. It's crazy. It's been almost an hour
I know.
that we've been chatting. Why don't we start wrapping up? What
Sure.
other like thoughts are on your mind? Like, because I know like you originally wanted to talk about this topic, but is there anything that we haven't covered that's still on your mind?
No, actually, that was a good exercise to go into 5 whys, because I feel like I really need it to revalidate myself again. Why do I need to go? Why do I need to spend this money to go into a training that I know that I'm gonna have a difficult time?
Yeah, maybe to like be more like philosophical at the end too, if you want to make a comment like that. I'll say I wanted to actually write an article on this. Basically, the questions I asked you, because I'm asking the questions to myself right now. When is enough enough? And part of the reason why I want to write that is because my day is pretty much like 18 hours sitting here all day in front of my computer. I work from the moment I wake up to the moment I sleep. Weekday, weekend. I don't really do anything else. And you have to think that there's much more to life than just sitting here and learning all the time, because there's a lot of other things that make a meaningful life. And I had another thought. I forgot about what that was. Oh, you were ending on the 5 whys and that exercise. Okay. I had a question. Now I forgot it. I got too deep in thought.
It's okay.
But okay. So what is, maybe we start somewhere there. What is that next step for you then? Because when do you graduate?
Good question. So officially in August or July, depending on how they end it.
A couple more months then.
Yeah, but I mean that's also officially like for my fellowship, as long as I fulfill a requirement, I do my project being responsible. I think they're pretty flexible, but the official time is August.
So if you were to pursue like the CS, were your thoughts on doing it part-time or full-time? I'm assuming it's part-time.
Oh yeah, definitely part-time. I probably well, yeah, I do. I still need to make money. I still need to live. I need to get good food. I need to join to the foodie crew. That's like my second hobby, is to eat good food.
Well, I don't know if that is of interest to you. I know like a lot of people, when they're pursuing some of these degrees, a big part of it is like it's expensive. So one of the things I considered 2 years ago was actually to do the NLM fellowship for Biomedical Informatics. I'm sure you've seen that.
Yeah.
Because they pay you and they pay for your master's.
Mm-hmm.
So, both Stanford and Harvard had a program. And so I was very intrigued with doing that. So like technically, if you need to make money, you can make money through the fellowship, get more training, get a master's, and you probably have a lot of great opportunities afterwards too.
That is true. I mean, that's one of the revenues I would look into, but then I wouldn't bet on it entirely.
Yeah. Okay. Well, as we wrap up, one more time I'll ask you again. Any other questions, thoughts, closing thoughts from you? Closing comments?
I don't know. I thought this conversation was very productive.
Okay, cool. Well, thanks everyone for tuning in. I know this was a big thank you to Kevin, because like, again, this was like a random thing. We were about to talk about this and I was like, hey, let's just do this on live stream. So yeah, thanks everyone for tuning in. Thanks people for asking questions, and cool. We'll probably have more of these conversations in the future, I'm assuming, because we're curious individuals, right?
Yep.
So. All right, Kevin, feel free to stay on. I'm just going to end the stream. It won't, so don't leave yet in the stream.
Okay.
Thanks everyone for tuning in. We'll chat next time.